Hi Y10, it's Miss Marsden. I'm going to take you through a lesson today on energy changes in reactions again. So the do now task is the questions are in your booklet. You need to have the booklet open from folder if you don't already, and it'll make it a lot easier for you if you are using the booklet throughout. So pause the video for as long as you need to answer the questions. These questions are a recap of what you did last week. So if you missed last week's lesson, please go back to it and please pause this video until you've finished last week's lesson. An exothermic reaction gives out energy to the surroundings and it will cause a temperature increase, whereas an endothermic reaction takes in energy from the surroundings and that causes the temperature to decrease. I've given several examples of each exothermic and endothermic reactions. If you didn't manage to get any, please just make sure you do make a note of at least one for each. So what I wanted to be able to do by the end of this lesson is to be able to recap the definitions of each type of reaction, just as we've just got started with. And I want us to be able to confidently describe the reaction profiles for each. And then I want us to be able to describe how to conduct the required practical for this topic. And we're going to look at some secondary data as well. This is just a recap from last week. So no new content, just a bit of revision. What I would like you to do is I'd like you to fill in the gaps to give me both a description and an explanation of each of the reaction profiles for both exothermic and endothermic reactions, okay? Pause the video for as long as you need to do this task, because I'm going to go through it on the next slide. So we're going to focus on the graph on the left-hand side to start off with, which is showing us the reaction profile for an exothermic reaction. So the product, which is what comes out of the reaction, has less potential energy than the reactant. And we can see that because the line for the product is lower down than the line for the reactants, as you can see. That shows us that energy has been lost, and we know that that energy has been lost to the environment. So if we move over to endothermic reactions, and we now compare the line for the products and the reactants, what we should see is that the products have more potential energy than the reactants, and that's because they've taken in energy from the surroundings. So they've taken in energy, and that's why the products have more energy than the reactants. So make sure you're confident with that. Again, if you're not, please go back to last week's lesson and please do a recap lesson going over this content. So let's move on to some new content, and we're going to talk about how you can investigate exo and endothermic reactions, okay? So in your booklet you have this question, exactly the same as what's on the slide now. So it says that if magnesium ribbon is placed into copper sulfate, a reaction takes place. The temperature of the solution rises. The products are magnesium sulfate and copper. So I want you to tell me, number one, what sort of reaction is it? I want you to tell me, is it endo or exothermic? And as a stretch task, you can tell me what type of reaction is it, bearing in mind that the copper is being pushed out. I want you to have a go at telling me 4 factors that could affect how big that temperature change is. And then at the bottom, you need to write a word equation for the reaction. All the information that you need is in the question if you read it fully. If you're in top set, I'd love if you could do a balanced symbol equation. especially 10A1, we went through this before lockdown, so you should be confident with how we illustrate reactions using balanced symbol equations. Pause the video for as long as you need to. So, the reaction is an exothermic reaction, and well done as well if you said it is a displacement reaction, okay? Displacement just means that the more reactive metal will push out, so it will displace the less reactive metal from the salt, okay? In this instance, magnesium is more reactive than copper, and you can see that copper gets pushed out and it gets left on its own. So the size of the temperature change, it could be affected by any of the following. Notice how I'm using specific keywords, okay? Copper sulfate is a liquid, so we always talk about volume. If you said amount, please correct that. Please say volume. The concentration of the copper sulfate. The mass of the magnesium. Remember, don't say amount. If you did, change it to mass. The surface area of the piece of magnesium. I'll also allow you to have the size of the chunk of magnesium. And then the word equation is as follows. Magnesium and copper sulfate are the reactants, what goes in. And then you should have an arrow separating the reactants and the products. The products are magnesium, sulfate and copper. Well done if you got the balanced symbol equation. You didn't need to do any balancing by adding any extra numbers, but superb if you remembered, for example, that sulfate is SO4. So that's a basic introduction into a practical where they're investigating the effect of time on temperature change. So there's loads of practicals that you can do for this topic, and usually it involves changing one of the four things that we've just identified. So the factors affecting temperature changes can be several things. So the mass of the solid reactants and the surface area of them, the concentration of the solutions being used, the volumes of the solutions being used. I'm using the word solution to describe any chemical which has been dissolved in water, like the copper sulfate we were just talking about. You can also have bigger differences in reactivity for displacement reactions, okay? So if you use two metals which are very different in terms of the reactivity, for example, calcium, which is very reactive, and copper, which is not reactive at all, you'd get a bigger reaction. You get a bigger temperature change. You have some space in terms of reflection space in your booklet. What I'd like you to do is just to make sure that you've written down each of these points which can affect the temperature change in a reaction, okay? Just make notes, for example, if you said the amounts of solutions, you can now make a note saying the volume of solutions, for example. So the practical that we're going to be looking at today is you're going to be investigating the temperature change during a reaction between sodium hydroxide, which is NaOH. You should know that that is an alkali. And we're going to be reacting it with hydrochloric acid, which obviously is an acid, okay? So what I'd like you to do, you've got the instructions in your booklet. I'd like you to carefully read and to highlight the following from this method, okay? I'd like you to tell me the volume of acid you would need to measure out, where you would put the acid, what volume of sodium hydroxide you need to measure out, and also when you need to take the temperature change. So I want you to highlight those 4 things in your booklet to demonstrate that you fully understand the method. So pause the video for as long as you need to. So you should have highlighted each of those 4 things, and we're going to come back to them throughout the rest of the lesson. So next thing we need to look at is variables. So what I want you to think about is, what are we changing? So the independent variable, what are we changing in this investigation? I want you to think about what we're measuring, the dependent variable. Please be specific. And then I want at least one thing that we are keeping the same in this investigation. So, what are we changing? We're changing the volume of the alkali that we are adding. Don't say amount, say volume. What are we measuring? We're measuring the temperature increase. Things that we need to keep the same. This is linking back to what you just highlighted. The concentration of each of the acid and alkali, and the volume of acid as well. So now we know what we're measuring and what we're changing. You've got some secondary data because obviously you aren't able to carry out an investigation like this at home, okay? So we've got some secondary data here, and what I would like you to do for each of the conditions, so each of the volumes of sodium hydroxide, what I would like you to do is to calculate the mean for each one, okay? Please remember that you need to get rid of any anomalies out of your data that doesn't fit with the pattern, okay? So can we spot any anomalies now? Yeah, I can spot one. 30. So please remove them before you calculate your means. Pause it for as long as you need to. Well then, please make sure you've removed your mean there, and it should be 24. But please check the rest of them. Please green pen them if you need to. You just add together your values for each one and you divide them by the number that you have, which is 2. Unless you add an anomaly when you don't need to divide it by anything at all. So, this is what your graph would look like. What I'd like you to do is I would like you to describe the pattern that you can see in the graph. So when I say describe, remember, I'm just wanting you to say what you see using specific figures. So for example, between 0 and 25 centimetres cubed of sodium hydroxide solution added, the temperature increases. What happens after that? Okay, so remember, say what you see like I just did, using specific figures. Break it up into 2 different points and separate it there. You might want to state what the highest temperature is. What happens after the highest temperature is reached? So, what we can see is that as the volume of sodium hydroxide solution added is increased, the temperature also increases. until a volume of 25 centimetres cubed is added, when the highest temperature of 34 degrees Celsius is reached. After this point, the temperature, it doesn't get any higher, does it? So what we can see, this line shows us that that is the volume needed to neutralise the solution, okay? Any more and you don't get the same reaction. So, how could we improve the investigation to pinpoint this exactly? So think about it, we're only measuring the volumes every 5 centimetres cubed. How could we pinpoint exactly where the highest temperature change is? And I also want you to tell me, what do you think the reason for this anomaly here is? It doesn't fit in with a pattern. Why might that be? So what they should do is they should repeat the experiment with more volumes of sodium hydroxide between 20 and 30, okay? So they need to take measurements at smaller intervals in terms of the volume, okay? We've just had to guess that using the graph, but if they would have repeated the experiment with more volumes, you'd be able to identify exactly what the amount of sodium hydroxide needed to neutralise that acid is. What could have been the reason for the anomaly? You could have said incorrect reading of the thermometer, for example. I've said that the reading is too low. So basically they might have taken the thermometer out, they have taken the reading before the maximum temperature has been reached. They might have taken the reading when the reaction had only half completed, for example. So please make sure you green pen that. So basically it's a very simple practical. You just add in they're liquids, they're aqueous solutions, okay? So you have sodium hydroxide and hydrochloric acid, and all you do is you add them together, you mix them together. But if we did that in a beaker, it wouldn't be very good to considering we're measuring the temperature, okay? So why is it better to use a polystyrene cup instead of a beaker? And also, why is it good to keep a lid on the cup, okay? Think about it in terms of temperature. Where will that heat go if we're using a glass beaker with no lid? Pause it for as long as you need to answer that question. So, it prevents heat loss, and it's good to prevent heat loss because we're going to get more accurate readings of the temperature change, okay? So if you said it stops heat being lost, great. Why is that? Make sure that you add on it's so that you get accurate readings of the temperature change. So, at the back of your booklet, you've got a set of exam questions which relate directly to these practicals which you conduct as part of this topic, okay? There is a YouTube link here which I'm going to add into the description for this week's lesson. So it'll get sent out on emails for you. It'll also be on the school website. And that'll help you be able to visualise exactly how is this practical conducted, okay? So if you're struggling in terms of being like, I don't fully understand what it is we do in this practical, please watch the video. Please remember to send your completed booklet to your class teacher. And also you still have to complete your weekly Educate quiz.